Hello. For this problem, or these three problems, we're using the Excel file hypothesis for mean. And looking at the first one, we're testing the claim that grade point average is smaller than 2.5. Smaller than, that would be what your alternative, or H sub 1. So we want the mean smaller than 2.5. That means the null would be everything else greater than or equal to 2.5. So that's why it's this. Now since it's pointing left, it's a left tail. To find the p-value, we come over here, we enter our sample size. Here, sample size was 80. The population mean comes from the null hypothesis, which was 2.5. Sample mean, the sample mean was 2.46. And standard deviation 0.08. Your alpha is your significance level, which is 0.01. And we wanted the p-value. So over here's the list of p-values. It was a left tail, so you use the first one. 1.28 times 10 to the negative 5. That means we're moving 5 decimal places to the left, so this would be 0. For the next one, they didn't give us the mean and standard deviation, they give us the data, and so you need to enter the data. So I'm going to enter it right here. 7 7 6 6 4 6 6 8 4 7 7 5 6 8 8. So you enter your data. Let me delete our previous answers. The average number of cavities that a 30-year-old have had in their lifetime is 7. Do 20-year-olds have a different number of cavities? So different means not equal to. That's why mu equals 7 and then mu does not equal 7. For the study, you use a t-test because your sample size is small. So we're testing not equal to, which would be a 2 tail. To find these values then, we come over here and we put our sample size, which there was 15 of them. The population mean comes from the null hypothesis, which is 7. Now to find our sample mean, here's our data. Mean is average, so you put equals and start to type average. Here it is right here. Double click it and highlight your numbers and hit enter. Standard deviation, same thing, ST. Oops, put your equal sign and then ST. There's 2 standard deviations, a population and a sample, so we double click the sample because this is a sample, not the entire population. And then we hit enter, and there's our standard deviation. Our alpha was 0.05 right here, your significance level. And hit enter. Now we wanted our t-value, -2, right there. The p-value, it's 2-tailed because it was not equal to, so here's your p-value. If the p-value is less than alpha, reject. If the p-value is greater than alpha, do not reject. Well, if we have -2, so the p-value is greater than alpha, because 0.065 is greater than a -2. So we fail to reject. The last one, let me delete these again. Test the claim that the mean GPA of night is smaller than 2.2, which means we'd be testing less than. So that would be this one. Our sample size from here is 35 people. Population, the 2.2 from your null hypothesis. The sample mean is from the sample, which was 2.19. Standard deviation was 0.06. And alpha was 0.1. Your t-values right here. Your critical value, those are to the right. The p-values are to the right. So they're over here. Sorry, the critical values. And it was two-tailed -1.307, which would be this one. Right here, because it was a two-tail. Oh no, this was the less than. So it's the -1.307. So on the two-tail, I keep saying two-tail, but it wasn't a two-tail. The last one was two-tail. This one is a left tail. So the left tail, your critical value is the -1.306, or rounded to 7. And our test statistic was this right here. Alternative hypothesis is less than a certain number. So then when you test it, you fail to reject.